Okay. All right, here we go. I want to give you a little, this is not for now. This is for you to look at over break, since we're kind of in the middle. We're toward the end, but we're kind of in the middle of something. This is a little worksheet over Unit 2 that sometime over break or J term you should get out and create a couple problems a day or something. I don't know. Something just to keep your brain kind of still functioning along these lines, okay? So it's not mandatory, but I think it would be helpful. Actually, you're always looking for points, so let's do it. Okay, not now though. Now we have to get ready for our exam, which, oh, by the way, is tomorrow, right? Okay. So, I found something I didn't like. The other class found something just incredibly confusing because I had left part of the problem off. So if you look at 2.5, there is already an F chart there. There should be a G chart. 2.5. There should be a G of X chart that looks like this. And number 2 and number 3 refer to this chart. Number 1 refers to the F table. 2 and 3 refer to this, which I didn't write down. So I'm not saying you have to do that, but if you were confused by what the heck was going on there, that, well, yeah, we can do this if you want, or we can do whatever you want. Charlie?
There was another thing that I just had no idea. I think this is like something wrong. But like for 1.4, number 1.
1.4. Number 1. Yeah. Okay, you know how to find the max. Okay, wait, first of all, well, we're changing from increasing to decreasing. You know that would be a maximum, right? Do you know how to find the maximum on your calculator?
Yes.
Okay. That problem, I think there is a maximum, but it's really hard to locate.
Really?
So it wouldn't be that. I'm not going to do this.
Okay, I was going to say it was like
Just, I made up a problem and I didn't double check it before I know that increasing to decreasing is a maximum and know how to find it on your calculator. Yeah. So, number 2 says, find the model without regression. So without going into stat calc and all that, find, well, basically I have 2 ordered pairs here. And if it is to be, well, I didn't even tell you that, it's exponential. Its directions are terrible, but it's supposed to be an exponential model. So that means that to get from this term to this term, I am going to multiply by something 3 times. So R times R times R will get me from here to here, from this term to this term. Now, what is the total multiplication over here? Because remember, whatever R is, I'm multiplying it to get from here to here. So wouldn't that be 9.1 divided by 16.8? The total multiplication. So R cubed equals that. Now, it doesn't say I can't use my calculator, it says I can't use the regression feature. So I'm gonna figure out what my R is. And I got, I don't know, 0.8152, does that sound like what you got? So R is 0.8152. R is literally the cube root of this thing. Right? That's what it is. Okay? Now, I need to write my equation for this thing. So what does an exponential look like? Just a straight up exponential, what does it look like? Y equals A times B to the X. And what is this number right here? That is my B. So Y equals A times 0.8152 to the X. Now I need to find my initial value, my A. What do you think? Okay, so, all right, so I'm going to see here for a second. So you're saying put in 4 for X. And 7 for Y. Oh, 4 for X. 16.8 for Y, I'm sorry. 16.8 for Y. Now, I don't need another equation because isn't there just one variable there? So 16.8 divided by that thing to the 4th. I got 38.0481. Somebody double check that for me. That look okay? So my equation, I'm saying, is 38.0481 times 0.8152 to the X. Now, do it with regression and let's see what happens. Only takes 2 points, so we're good. Exponential. Oh my goodness gracious. Exactly the same. Now what you were talking about, Celeste, when you said build 2 equations, I could have done that from the very beginning and not done this. Okay? So you could have, right from the very beginning, built the equation 16.8 equals A times B to the 4th, and then 9.1 equals A times B to the 7th. So that would be fine. In the course of doing that, you're going to end up doing this right here. So I just did it first, but that will work. That is when you set up your 2 equations, so right from the very beginning. All right, what else? Anybody find anything else as you're studying? Yeah.
1.12 number 3.
112. Q is my function. Okay, and I'm supposed to show a horizontal dilation of a factor of a half, finding A, B, and C. So if I have a horizontal dilation with a factor of a half, what does that do for me? I'm finding A, B, and C. B would be 2. So now I know B is 2. And a vertical dilation by a factor of 3, A. And a vertical translation by 1.
But how would you graph that? Just like
Does
what
it
would
say
the,
graph it?
no, but just like if you have to on the test, how
You,
would we?
you have to know what function Q is.
Yeah.
You don't have it, you can't graph it, because Q isn't, you don't have a starting point.
Yeah.
Yeah. You would have to have, you have to have something to start with, and then you would make these changes to the graph. But, yeah, we can't with this one, because we don't have enough. So practice there, we're just making sure you understand what these numbers do.
Yeah.
Can you do 2.44?
Now I do have a function Q, which is negative 2/5 to the negative x. And I want to know, is it increasing, decreasing, concave, up or down? So I always personally start with a picture. Negative x, but that bothers me a lot. So what is that negative x? That's going to turn this over. Right? Now, let's take this out of the picture for a minute. That number is bigger than 1. So isn't that just going to be a regular exponent? This right here would just be a regular exponential. But when you put a negative coefficient in front of it, it's going to turn it into that. Paisley, you with me? Well, that is, what are my options here? That is definitely decreasing, and it is concave down. All right, what else?
You did 2.7.
2.7, numbers, find H of x, what is the Alright, so what do I know about f is the square root of 3x minus 5, and h is 7x minus 2. So I'm gonna plug f into h. So f into h. So it's gonna be 7 times the square root of 3x minus 5 minus 2. That's composition. Now, tell me about the domain. Well, the domain in the beginning, the domain of the original function, if I'm plugging f values into h, I can't even talk about f unless x is bigger than or equal to 5/3. So my domain for f, function f, is bigger than or equal to 5/3. That's my domain for f. Now when we do a composition, this is our beginning function. So whatever we plug in is going to have to meet that criteria, right? It's going to have to be in the domain of f. All right, then we do all this stuff. Ultimately, we also have to be in the domain of the composition. Well, look here. Is the domain of that any different than this? So this is the domain. This is the domain of your answer. Now, when it might change is, let's suppose, we ended up, let's say H maybe was this function. So then when I built my composition, it would look like this. And now, in the beginning, X could equal 5/3. But now it can't. So that would change the domain then of the final answer would change. It would be just 5/3. If that had been the original.
So if you have like an original function that's a square root, but then like when it's put into another, it gets squared, could you still not have the?
So the domain of the composition consists of the domain of the original and the domain of the composition itself. Okay, it has to meet both criteria. All right, so even if you did square it out, even if this had been, a squared thing, you still can't let X be less than 5/3 because you couldn't do step 1. This is 2 different steps, and you gotta be able to do step 1 to get to the other steps. So the domain of the original and the domain of the composition, that's where you get your answer from. Your total domain of it. Okay. All right, what else? Anything else? I have 2 papers to hand back while we're waiting. Yes, Charlie?
It's not in the review, but what was the equation? It wasn't compounding continuously, but it was like similar to that, it's like 1 plus.
Yeah, I'll put it up here in a second. You're talking about the compound interest formula? Let me put the formula up here and then we're gonna, another question. Right, here's the compound interest formula. Charlie? So Charlie, there it is.
Thank you.
And N is the number of times a year you compound, so
No, no.
quarterly it would be 4.
Okay,
Okay?
thank you.
All right, what was your question?
On the extra practice, the 2.63, I got like the same numbers on the answer key, but the final answer was different. Like I got the same formula or model.
So there are 61 crickets. And then 5 hours is 275. And we want to use this is very similar to, what we just did. So if it's exponential, and we're gonna be doing the same thing, we'll multiply 3 times. So we're gonna have R cubed 275 over 61. So I can find I'm looking for this equation. And I'm finding, right now I'm finding B. So it looks like R is going to be, actually, did you do it by hand or with your calculator?
By hand.
Okay. It doesn't really say which way I'm supposed to do it, so, all right, so I got my B to be about 1.6520. Is that what you got?
Yeah.
Okay, and then I said 61 equals A times 1.652 P squared. Did you get 22.353?
Yeah. So then I plugged it in and I got 3,683. But that's not what the answer key said.
Well, sometimes the answer is right.
I just didn't know if I was doing something wrong at the end.
So that's what our equation looks like.
Yeah.
And then what does it say?
10 hours. Yeah. I didn't know if the answer key said 8. That's what I got.
Oh, wait,
Did you get 3,300?
okay.
All right. Anybody else? Yep, plus 2.93. 2.9.
And this is the original.
Okay, so let's remember, the change of base formula allows us to change any logarithm of any base into any base we want. So, like, if I had to evaluate this number, I would do log 12 divided by log 6. Right? So it's this thing is a base 6 logarithm. This is a base 10 logarithm. I could make it base 7 logarithm. I could make it base whatever I wanted. So what if I said ln 12 over ln 6? Now it is a,
Would it just stay like that? Would it stay like that? Or does it need
Yeah.
to go?
yeah, is it now in terms of natural logarithms? Yeah, and it might have been the other class we were talking about why this is even a thing. Didn't used to have calculators that had that button on them. And then, when I was taking this class 50 years ago, there weren't calculators, period. So we needed to look, if we needed to change something like this, we needed to either turn it into a natural logarithm or a common logarithm, so we could look it up in our table of logarithms and get the numbers up there. Those were the only ones we had there. Not really an issue anymore, because you can just type that in. All right, what else? I think we have 5 more minutes. Yep, we got 5 more minutes. We'll do a couple more problems.
Can we do 2.13, number 9?
Yeah, the inequalities are not on the exam. For me. Now, everything else there you should be able to do. And a couple of them I think we've already done, but I'll do anything else from there is fair game. But we didn't get to the inequalities, so we're going to put those on the exam. Alright, anything else? We'll do that, it'll be the first thing we do when we come back.
Can you do two?
Let me do 6.57.
Number 7. Did I do that one already? I didn't do that
Oh,
one
no,
already?
you did. Yeah, you did.
I think I thought I
My
did.
bad, I have it right here.
Alright, Basil, what was your question?
I was gonna ask the same thing.
I think I did that one already, didn't I? Or maybe it was the other class? No, she has it down. I did that one already. So, an interesting one along those same lines, what if we had a logarithmic function? And we wanted the inverse of it. Okay, so this isn't on the sheet, but it's the same as the question that we had. How do we find an inverse? Step 1, switch the variables. So we're going to start by saying x equals 2 log base 4 y plus 2 minus 8. And then we have to get y by itself, right? So maybe we'll add 8 and divide by 2. How does that look to everybody? So far, so good? Now, we have to get y by itself. What do you think? Loop, doo. We're gonna say 4 to the x plus 8 over 2 power equals y plus 2. And then subtract. So 4 to the x plus 8 over 2 power minus 2 is our inverse. When we did that problem last time, we started with an exponential, and when we got through, our inverse was a logarithm. Well, when we start with a logarithm, our inverse is an exponential. All right, 2 more minutes. We'll do 2 minutes.
Do 2.10 number 3.
210 number 3. Sketch g of x equals log base 1/2.
Does the 1/2 move the graph like to the left or right or up or down?
The 1/2 has an impact on the graph.
Yeah.
Does anybody, okay, let's start with, here's your basic logarithm. Okay, this is your, that's just your basic logarithm. Who remembers what a base of 1/2 does to your picture? Anybody remember? Let's say, it's the same as putting a negative coefficient in front of it, because 1/2 is 2 to the negative first, so that just negates the thing. So it's going to end up looking like